Hi, I'm Alex.
I'm Jay.
I'm Ethan.
Today we'll be explaining to you the physics of riding a bicycle.
Have you ever wondered why you are able to ride a bike with such ease or even without steering? Today we'll be teaching you the physics of riding a bike and what makes it so easy for almost all humans to ride. Some physics concepts that we will be going over are gyroscopic force, center of mass, torque, and velocity. When riding a bike, the wheel is spinning at a certain angular velocity, and this angular velocity creates a gyroscopic force. This means that the wheel does not want to shift from its axis of rotation.
While this gyroscopic force does have an effect on the bicycle, creating a small torque to keep the bike up, the important factor is riding a bike is the steering. This is what allows you to move the bike under your center of mass, allowing you to stay up. Without the steering, it is nearly impossible to stay up, and you will fall just as quick as a bike with zero velocity. This can be seen in the video we filmed of a bike where the steering is locked up. It can also be seen that the bike will stay up on its own with a high velocity. This is because gyroscopic force from the wheel wants to stay up, so when the bike starts to tilt over, the wheel moves under the center of mass of the bike and keeps it up.
Before we look back at the videos and diagrams, we first want to talk about one of the most important factors when riding a bike, that's gyroscopic force.
So what exactly is gyroscopic force, Jay? Well, Jay, gyroscopic force is defined as a rotating gyroscope with the angular momentum vector pointing upwards exhibits gyroscopic motion as it resists falling over. Gyroscopic motion is the tendency of a rotating object to maintain the orientation of its rotation.
So to more easily explain Jay's thoughts, we created this diagram showing the torque that is created from a wheel spinning on an axis with a torque applied on one side by gravity. The wheel spinning creates an opposite torque on the other side, which keeps the wheel vertical but also creates oscillation around the rope.
Here you can see that as the angular velocity of the wheel decreases due to friction, the torque/gyroscopic motion also decreases, which causes the wheel to tilt from gravity's torque. As you can see in the first bike clip, the bike moves in a forward direction after it was pushed. The bike was able to stay upright because the steering was constantly adjusting to balance due to the gyroscopic force generated from the wheel's angular velocity and torque.
Now, as you can see in the second clip, the bike falls over. The bike falls over because the steering was not corrected since it was stationary, meaning there was zero angular velocity to generate a gyroscopic force to keep it upright.
The third clip displays the bike being pushed when the steering was restricted with the rope. You'll be able to see the bike fall over. It falls over just as easily as the bike that was stationary. The reason why the bike fell down this time was because of the force of tension that kept the steering restricted outweighed the gyroscopic force generated by the velocity of the wheels. Because of this, the steering wasn't corrected and that caused the wheels to shift from its axis of rotation and that led to the bike falling down.
Now, in the next few clips we're going to be looking at, we'll learn about something called the caster effect. Normally, as a bike tilts, our natural instinct is to steer in the same direction in order to keep the bike upright and have the wheels aligned. In the video clips we displayed above, it shows how the wheels of a bike act in the same behavior. The wheels maintain alignment because as the bike tilts towards a certain direction, the gyroscopic force generated from the wheels' velocity moves the wheels to the other side to keep the wheels straight and aligned. As the wheel increases in velocity, the bike is able to correct its steering because a greater gyroscopic force is generated. But a certain velocity is required, otherwise the bike won't be able to correct itself fast enough. This is one reason why it is easy to keep balance on a bike. Okay, so here we have teenage Mr. DePriest. And he's just riding a bike down the street, leisurely ride, and he's taking a turn here. So in the green right here, we have his center of mass. And one of the forces that's acting on his center of mass is going to be the force of gravity. Now, on the tire that's in contact with the ground, there's going to be another force, and that's going to be the force of friction. And then, of course, you're always going to have the normal force, opposing gravity. Because Mr. DePriest is riding in a circle, this is going to create a force called a centrifugal force. And in order to counteract this centrifugal force, he needs to lean his center of mass in this direction so he will not fall over. If Mr. DePriest decided he wanted to turn left, and he turned the steering wheel so the wheel would then go in this direction, and he didn't lean into the turn, then because of the centrifugal force pointing this way, his body and the rest of the bike would also go this way, causing him to fall over.
In conclusion, while riding a bike seems very simplistic at first glance, as you have seen, there are actually many physics concepts that can be applied to bike riding. Just like the few topics that we covered in our video, like the gyroscopic force and torque from the wheel, the velocity and how it affects balance, and finally the center of mass while turning.